Hey there aliens, in this video we'll solving the lead code question 62, which is unique paths problem. So we have been given a m into n grid, and there is a robot on the top left corner at 0 into 0 index, and what we have to do is we have to count the total number of ways in by which we can reach at this finish index, means total ways, and there is a constraint given that we have to either move down or right. So if this robot is here 0 index, so he can move this side, means right or down. From here he can move here right or down, and by this way we have to calculate the total number of paths he can reach at this index finish, the star, which is m minus 1th and n minus 1th index. So we'll see this using an example. So this example is very long, I will not take this, and I'll take this example as m equal to 3 and n equal to 2, 3 rows and 2 columns. So what we have given is we have a robot at 0 index, and we can either go this side, means right side, or go down. From there he can move right side or down side. From here right side or down. And if he is reaching at this index, well, then what we'll do is we'll return 1, means we have reached at this index. And we have to take the condition, we have to keep in mind that it should not go out of bound, as it's reaching at this, you can see, out of boundary, out of matrix. So we will return 0, means does not find any path. And if it is reaching at this index n minus 1th index and n minus 1th index, then we'll return 1, as we have found one path from this. So likewise it will work. And similarly for this this index also, it will call this function right side or down side. And from there also, if it is reaching, you can see it's reaching at this index, and from this you can find this path at this below side. So it's there is a two path, one is from this side and the second is from this side, two paths till now. And it said there is a one call also at this index, as we are calling the recursively. So from this side it will go right or go down. And this way also he is looking at this path that we are reaching at the final index, final grid, using this path also. So go right or go down, and total number of path we have to count. And keep in condition that we should not go out of bound, means do not go left side from the boundary, up or right or down, only traverse inside the matrix. And if you are reaching the index, then count that index. Let us see the code how we'll write. So first we will write the boundary condition, and then we'll check that if we have reached that, then we'll count. Simply we'll call recursion and we'll check that. So we'll write a function name count paths, and we'll return that. Initially we are at the 0 and 0 row and 0th column, means 0 index, and this is a value of a row and column size. And we'll write the function name now. This is a column path, and this is a index I, index j, and this is a row and this is a column. So what we'll do is, now let me write the row name and column. So initially we'll check that if I is less than 0, means out of bound, left side, and j is less than, or j is less than 0, or I is out of index. Similarly for j, it should not go, its name is column now, and this is not m, this is a row. Okay, so in this condition we'll return 0, means we do not find any path. What we are doing is I less than 0, means if it is this side, or j less than 0, means it is going up, or I greater than equal to row, means this is this side, or j greater than equal to column, means downside. Out of grid it should not go, we have to handle this case. So in that case we'll return 0, means we do not find any path. else we will check the condition if we have reached the index, means I equal to row minus 1 and n, j equal to column minus 1 means final index. So we'll return 1. Yes, we have found the path. Okay, and now we'll call for the other conditions. We'll check that by going right side or by going down side. So now and we'll store the variable, means right count path and j plus 1 row and column. J plus 1, you can see I is same, but j plus 1 means next index, which is right side it's going. And similarly for down also we'll calculate count paths I plus 1 j row and column, and we'll return the total number of count paths right plus down will return. And let us compile it. Yes, we can check, you can check that for this input it's giving this right value. Let us submit, and you can see we are getting a time limit exceed. Now why is that? Let us see the reason behind that. Reason is, you can see here, for all these paths what we are doing is we are calculating the values again. You can see using this path we are reaching using this path, and same for this path. If we are reaching at this index, then we are calculating again this value. So what we'll do is, for other larger matrix, if we are reaching at the same index, same grid which is giving the right path, so what we'll do is simply return from that index, from that means grid, that yes, we have found the right path. We don't have to calculate the values again. So this way we will not calculate the already calculated value. So, and in this example 3 into 2 we found the three total values, total number of paths. And what we'll do is we'll store the value. You can see in the question it's given that maximum size would be 100, so take one larger than it so that it should not overflow. So I'll take a matrix size, two values, two variables. You can see in this question two values are increasing and decreasing, means I and j. So we'll take the matrix size 2, 2D matrix will take, and initialize it as 0, as initially it will not have any path, so it will be initialized as 0. And we'll check if we have calculated the values already. If dp of current row and column values has been calculated, means does not equal to 0, means we have calculated the value. So simply return the dp of return the current rows and column values. Okay, and after that what we'll do is we'll store the values which we have calculated earlier. Simply this will do our work. Using these 3 line of code, we are calculating our, we are storing and we are returning our values if we have calculated the values already. Let us run and check. You can see we are getting the values. Okay, we are getting the right summation, and it is satisfying our constraint. So what we have done, let us sum up the total code. Initially we took a dp size of 101 and 101, 2D arrays, as we the two values are, two variables are there, which is increasing, which is changing. And initially we are on the 0 position, 0 index, 0 rows and 0 columns. And if dp value has been calculated, so return the dp current values. And we are checking that if it is out of index, do not go beyond the matrix, and if we are going beyond, then return 0, as we do not find any path. And if it's reaching at the final position, final grid, then return 1, that's yes, we have found the path. Else called into the right side, as its question has been given that either move down or right. So for right path, we'll call the right path and calculate the values if we have found the path, or call the downside that if you are finding the path using down, and to return, first return store the values in the dp array so that we can use it later on, and then return the value. So simply it will doing. So this was all about the problem. If you like, then hit the subscribe button and let us meet in the other problems.